Good morning. Today we're going to look at graphing rational functions. So let's start off with this rational function right here. Let me take one step back real quick to give you the parent for the rational function. The parent, okay, is y equals 1 over x. Y equals 1 over x. That's the parent function. So, determining the domain. Well, what I like to do first is I like to determine the vertical asymptote, and then from there I like to write the domain. So remember what we do. We take our factor in the denominator, which is x minus 1. We set it equal to 0, and then we solve for x. So our vertical asymptote is x equals 1. Okay? Which means that at x equals 1, we have a vertical asymptote. So let me use a darker. And we use a dashed line for our vertical asymptote, x equals 1, which means that the domain of the graph does not include 1. So we would say x does not include 1. So all real numbers except for 1. Okay? Horizontal asymptote. So we get our horizontal asymptote from our numerator. The degree of our numerator and the degree of our denominator. So the degree of the numerator is 1. And the degree of the denominator is also 1. So what we have here is we have 1 equals 1. Now, until you have it memorized, you're going to need to look back at your notes that we took on horizontal asymptote. Let me see if I have mine here. Okay, so looking back at our notes on horizontal asymptotes, there are 3 rules, and we have the degrees being equal, so this would be right here. If they're equal, then the horizontal asymptote is going to be found at y equals a over b. Remember that a is the coefficient of the highest powered variable of the numerator, and b is the coefficient of the highest powered variable in the denominator. So the coefficient on the x to the first is 1. The coefficient on the x to the first in the denominator is also 1. So it's going to be y equals 1 over 1, or y equals 1. So now we can draw that in at y equals 1. So we're going to go up 1 unit, and we're going to draw in our horizontal asymptote. You can see that. Should make it a little bit darker here. Okay, still a little light, but that's okay. Alright, so now we're going to go ahead and fill in these tables. So the first value that I would choose would be, okay, I would not choose 1. Let's choose 0. So 0, if we choose 0, if we plug 0 in, 0 plus 2 is 2. 0 minus 1 is negative 1. So we're going to have 2 on the top and 0 minus 1, so negative 1 on the bottom. So our y value is negative 2. So 0, negative 2. Okay, let's try negative 1. So plugging negative 1 in at the top, negative 1 plus 2, negative 1 minus 1, so we get negative 1/2. So at negative 1, we're at negative 1/2. Okay, let's try negative 2. Negative 2 plus 2 is 0. Negative 2 minus 1 is negative 3. So our y-coordinate is going to be 0. So at negative 2, we're at 0. Okay, so we're going to draw our graph in. It's going to go along this asymptote. It's going to curve through these points, and then it's going to curve along our horizontal asymptote like that. In general, our graph's going to curve along the asymptotes. Okay, let's look for this side. Okay, so let's go over 1, 2 units. So 2 plus 2 is 4. 2 minus 1 is 1. So this y-coordinate is going to be 4. So 2, 4, 1, 2, 1, 2, 3, 4. Okay, 3. 3 plus 2, 3 minus 1, 5/2, that's going to be 2.5. So 1, 2, 3, 1, 2.5. Let's do 4. 4 plus 2, 6. 4 minus 1 is 3. 6 divided by 3 is 2, so 4, 2. So 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. That doesn't seem right. Did I make a mistake somewhere? Let's see. 5/2 is 2.5. 3, 1, 2, 3, 1, 2.5. Oh, I guess so. So 4, 2. I guess my half isn't a little high enough here. So here we go. We're going to go along the vertical asymptote. We're going to curve through these points, and then we're going to go right along the horizontal asymptote, just like that. And that's how we get our graph. I'd say at least 3 points on each side will help us make a nice curve. You can do more or less. Well, less would probably be not so good. Okay, let's look at the next one. So let's start taking some shortcuts here. So domain, okay, so what value can we not have here? Well, we cannot divide by 0, so the value that we could not have here is negative 2. So x cannot be negative 2 because negative 2 plus 2 is 0. So that means we're going to have a vertical asymptote at negative 2. Okay. Okay, so negative 2 on the x, so negative 1, negative 2. Horizontal asymptote. Let's look at the degree. The degree of the numerator is 0. The degree of the denominator is 1. So we have 0 is less than 1. Okay, the degree of the numerator is 0. The degree of the denominator is 1. So let's take a look back at our notes. If the degree of the numerator is less than the degree of the denominator, then the line y equals 0 is the horizontal asymptote. Okay, let's go ahead and put that in. I don't think we're going to see it very well, so since it's right on the x-axis, I'm going to extend it out past so I can see that that's where the horizontal asymptote is. Alright, so I want to choose some points to the left of the vertical asymptote. So that's going to be negative 1, negative 2, negative 3, negative 4, and negative 5. And then I want to choose some points to the right of the vertical asymptote. So let's choose negative 1, 0, and 1. Okay, so I plug these points in for x to get my y coordinate, and then I graphed it. I plugged the point in for x to get my y coordinate, and then I graphed it. And then I drew the curve along the asymptotes through those points. Now let's do this side. So we have 3 over, plug the negative 1 in, negative 1 plus 2 is 1. So we have negative 1, 3. So negative 1, 1, 2, 3. Okay, plugging 0 in. 0 plus 2 is 2. Get 1.5. So 0, 1.5. Plug 1 in. We get 3 over 3, which is 1. So we get 1, 1. Okay, going along the vertical asymptote, curving through those 3 points, and right along the horizontal asymptote. Okay, one more to do. So, first of all, taking a look at this, what can x not be? X cannot be 1. Pretty obvious, because 1 minus 1 is 0, so can't divide by 0. So this domain is all real numbers except x cannot be 1. Okay, vertical asymptote. Again, that's going to be x equals 1. Let's go ahead and draw that in quickly. Nothing new here. Hopefully you're getting the idea here. It's starting to sink in to your memory. Okay. Horizontal asymptote. The degree of the numerator is 2. The degree of the denominator is 1. What does that mean? Greater than numerator, greater than denominator. No horizontal asymptote. Okay, so you'll have to look back at these until you have them memorized, but please do memorize these rules for horizontal asymptote. So we have none. Okay, so let's choose some points to the left of the vertical asymptote. So we're going to choose 0, negative 1, negative 2. And to the right of 1, we're going to choose 2, 3, and 4. Okay, plugging in. 0 squared is 0. 0 minus 1 is negative 1. So 0, 0 is our first point. Plug negative 1 in. Negative 1 squared is 1. Negative 1 minus 1 is negative 2. So we got negative 1/2. So negative 1, negative 1/2. Okay. Negative 2 squared is 4. Negative 2 minus 1 is negative 3. So this is going to be negative 4/3, or negative 1.3 repeating. So we're going to approximate this. So negative 2, negative 1 1/3. It's going to be about right there. Kind of looks weird, doesn't it? It's like, okay, where's the curve here? This is a little bit different. Okay, let's look at the other side. So how do we draw this graph? Well, take a look at my calculator. I plugged it in, x squared divided by x minus 1, and then I graphed it. Yeah, it looks kind of weird, doesn't it? But use your calculator as a guide here on how you should draw this graph. So notice this one kind of comes up at an angle and then curves down quickly. So for this one, we're going to draw a graph going up through those points and then curve down very quickly through to that vertical asymptote. Same thing with this, along the vertical asymptote through that first point and then off this way very quickly.